Good afternoon. My name is Alan MacNeill, and this is my first presentation for the DATA670 Data Analytics class on my project evaluating pesticide impact on avian population for the DATA670 seminar being taught by Professor Dr. John McKeeby. So we'll be going over the status of the project thus far, the data that will be being used, lessons learned, and next steps moving forward. So we'll be beginning with an overview of the project itself. The data analytics problem that we're analyzing is asking the question, is there a direct relationship between the amount and type of pesticide that is used in an area, either agriculturally or in residential use, and the avian population in that same area? Now, we know that it's physically impossible to remove all pesticides from agriculture. It would be literally impossible to feed the population of the world without using some chemicals. But in a perfect world, we should be able to determine which are more or less harmful to the population of animals in general, not just birds, but birds and therefore creatures that feed on birds and etc. through the ecosystem. And we could determine which pesticides would be more effective, more able to be used to maximize that crop output while minimizing damage to the remainder of the ecosystem. This is an initial step in that process, which is just determining which pesticides are most harmful, how harmful are pesticides in general, etc., and focusing on avian populations. This will hopefully help frame the question for future research, and help maybe guide some decision making, etc. Ideally, with a very long-term goal of reducing the impact of them. So this is why I'm choosing to focus specifically on on birds. According to many studies, the avian population in the United States has fallen since 1970 by as much as 30% for many types of birds. So over the past 50 years, we've lost as much as a third of some types of bird. Now, there's a lot of explanations for why this could be occurring. Increasing human population, thereby squeezing out environments, stuff like that. But among those possible causes is a question to be considered. Is there any possible impact of the ever-increasing use of pesticides and other agricultural chemicals feeding through onto and impacting the bird population? So this project, as stated, intends to study, is there a direct correlative link between increased use of various pesticides on the crops in the United States and a decrease in the avian population? Additionally, we also are going to try to focus a little bit and see, are there particular types of pesticides that are more or less harmful to the local avian population? Now, many researchers have looked at this question. For example, two researchers, Katagi and Fujisawa, in 2021, performed a study just figuring out how pesticides are metabolized in birds. So basically, they've determined that the straight ingestion of pesticide can be harmful to an avian creature. That makes sense. I mean, it is poison. Yes, it's poison that's designed to kill a bug, but it's not. Some birds are not that much larger than some bugs, really, if you think about it. And some other researchers in 2020 also began to study a similar question. Li, Miao, and Kana created a paper that showed that there is a statistically significant reduction in bird biodiversity. In other words, the number of species and the health of those various species in a particular area. In the 6-year period, 2008 and 2014, relative to a counterfactual without neonicotinoid use. Neonicotinoids are a particular type of chemical, a particular type of pesticide that they focus their study on. And we will also be including those. We'll also be including other pesticides as well. So basically what they showed is a statistical likelihood that the presence of neonicotinoids reduces bird biodiversity. So the primary data source we're going to be using, which is a thing called the North American Breeding Bird Survey, NABBS for short, is widely considered as one of, if not the definitive source for historical avian population data. As an example, in 2017, a researcher by the name of Rosenberg used the data that's in a previous release of the survey that we're doing to work on new metrics of conservation urgency, as well as setting population objectives for tracking progress towards meeting conservation goals. So he used this data that we're reviewing to basically model what would be a better bird population. And just a very quick review of just the United States Geological Survey website alone shows that over 30 articles cite this data set just listed on that website, never mind the rest of the universe. This website is, if you want to know anything about birds in populations in the United States, this is your data set. The way that it's gathered is considered to be scientifically rigorous. Essentially, they go through and they have a number of, they call them routes. It's a series of 50 stops that are point on the map. So literally, they've got a latitude and a longitude. Start here. You wait for 3 minutes. You count all the birds there. You move to the next point. You wait 3 minutes. You count all the birds there, et cetera, et cetera, et cetera, through a 50-stop sequence, and that sequence is the same year after year. So it's ideal to determine, last year there were 15 starlings and 30 finches here. This year there are 10 starlings and 5 finches. Doesn't necessarily tell you why, but it does tell you what's going on. And that data has been gathered for over 40 years, with the notable exception of 2020 due to COVID. But so you have a nice long historical database of how many birds were where across the entire country. And that's great data. However, there are some gaps excuse me, in the research when we're talking about the effects of the chemicals on that bird population. So as we stated earlier, Lee, Mio, and Kana researched the question, but only across the neonicotinoids, which is one particular type of pesticide. We have data available to us, so we're going to try to cross across multiple sources and see if the sort of result that they received comes across all types, if there's a greater or lesser descriptive, a greater or lesser effect across the types. Additionally, the model that they produced doesn't indicate really just how damaging in their case, neonicotinoids are. They don't say it caused a 7% reduction in avian population. They just said there is definitely a statistical effect. They don't quantify it. We are hopeful that we'll be able to quantify it. Additionally, one of the other things that we're hoping to accomplish here is that one of the data sets we're going to be using, a thing called the Estimated Annual Agricultural Pesticide Use for Counties of the Coterminous United States, that survey is under attack as not being able to provide useful analytic value in exchange for the cost that it costs to assemble the data in an annual year. We're hoping that we're going to be able to show at least one way that that data can be useful as a tool to get a perfect handle on the various market basket of chemicals that are used in a given county and its effect on, in our case, the avian population. So those are the gaps that we're hoping to address with this project. So this project's importance is stressed by the fact that avian populations are a critical component of the ecosystem. For starters, avian populations serve the overall ecosystem in many ways. Bird droppings serve as a fertilizer for crops. Birds of various sorts act as pollinators for various crops. And also carrion birds, they recycle dead animals back into nutrients, returning those nutrients into the ecosystem. And excuse me, the avian population has been falling since 1970, again, as much as 30% for many types of bird. There are many explanations for why this could be, but among them is the possible impact of those pesticides, and we want to get a handle on that. There's a lot of ways that pesticides can impact birds. It can directly kill the birds, just, eat it and die. It can also cause chemical changes in birds. Perhaps the bird lives, but they're unable to reproduce effectively, or they may not live as long. Or finally, pesticides, by design, kill the pests. Well, the birds eat the pests. If the food's not available, you're going to have a malnutrition problem or just outright starvation for the birds. So having an understanding of the impacts of these questions is ultimately very important for the ecological health. Excuse me. There are 3 key performance indicators that we are going to trace for this. First off, we're going to trace, can we build a statistically relevant relationship between pesticides and avian population? This is measurable because we're going to get measurements for how statistically relevant and how strong is the relationship. So that's a key performance indicator. Obviously, the better model we can create, the better the project's going to succeed. There's another question about another indicator of, can the model logically be extended forward to provide predictive recommendations? Does the model provide time series that lets us say, hey, if we continue on this same track, by 2050, this is what's going to happen. If the model is very noisy, or if there's no strong correlation, it's a weaker model. It's not as effective on this run. And finally, we're going to make sure that the model encompasses the majority of the data that is available in the system. Some models occur where they find a huge data source and they start zoning in and zeroing in and zeroing in and zeroing in until they cover a very, very, very teeny tiny piece of data. You can't extrapolate that. We're hoping that this will provide a generally referenceable model across the field, and the wider a net that it casts, the better the model is. Now we're bringing in 3 separate data sets on this. We have a data set that we were just discussed about in detail about avian population. That's from the 2023 release of the NABBS. We're using 2 separate proxies for pesticide use data. One of them is that estimated annual agricultural pesticide use for counties in the conterminous United States, a county by county measure of what chemicals are used. We're also going to be leveraging a database that the United States Department of Agriculture provides, the Pesticide Data Program. That provides a status of the pesticides that are actually present on food in the ecosystem. So those are the 3 primary data sets we're going to use. Let's dig into a little detail here on the avian population. That North American bird survey it's stored in a complex format. There's multiple tables that get joined together. There are 4 that are of primary interest for this study. The first one is a state-by-state count of birds. It's an assemblage of the 49 state files. They don't survey Hawaii. They do survey Canada, but we're filtering that out. And it's just the primary counts of the birds of the survey. Then there is geolocative data about the routes and quality information for the routes. There's data on interruptions that may impact birds, cars, other loud noises, etc. And then there's also information about the weather. We're going to dig into each one of those in detail here for a second. So the first table, bird counts, like I said, it's the aggregation of the 49 state-by-state historical count files. So there's one for Alaska, one for Arizona, etc., etc., etc. The data is of very high quality. There are no nulls in this data table. There's no unaccounted for data quality issues. There's several data points that matter. There's a state identifier or route identifier. I described routes earlier. The year of the survey, an identifier for the species of bird. And then there are aggregated counts. So a sum of the top 10, of the first 10 stops, the second 10, third 10, fourth 10, fifth 10, along that route of the species found on the route in the state on the year. And then there's also a species total, which is kind of the grand total. So those are the numbers that we have from that table. Then routes is a separate table that can get joined in and get connected. It gets connected in on the state number and the route. And it provides the detailed latitude and longitude for the start of the route, so that allows us to geolocate, locate what county a route is in, that sort of thing. There's also some stratum and region data that indicate what is the, tells us about the area. What kind of land is it? Is it tundra? Is it a basin? Is it field? That sort of thing. Or there's also 37 bird conservation regions across the United States. It also indicates what region that's in. And that may be a split that we can use. Then vehicle, as I said, it's a little misnamed. It's really more interruptions. It contains two things. First off, it's a tally of the cars that passed the survey point. And it's also other excessive noise sources. There was an explosion, that sort of thing. That data is tracked in here. The meaningful data points are, it gives you the route data ID, which allows you to tie back to the other tables. And then at each of the 50 stops, how many vehicle interruptions were there and how many excessive noise incidents were there. The logic being that noisier environments are going to have fewer birds. So we're going to follow that through, and we're going to tie that information in. Then finally, there's a table about weather. It's very similar to the vehicle in that you can tie these observations into the primary route data. And then it gives you information about the temperature, the wind conditions, and the sky conditions. Is it cloudy? Is it rainy? Etc. That allows us to find data points where the weather is unusual. These surveys are always done in late June or early July, and they try to shoot them at about the same time of the day. However, even with that, some day may be rainy or even stormy, versus another year it may be perfectly clear at that time. As a result, birds are less likely to be flying around and be observable when the weather's bad. So, a one-year data point where there was a tornado rolling through the area, the fact that they didn't see any birds, not terribly surprising. So this is going to allow us to control for that. So that's very valuable data that way. So that's our bird count. Now, we're going to tie that to two separate measures of pesticide use. The first one is a use estimate, which is based off of, they give us annual CSV files that list for each compound, year, and county. They provide two estimates of the high and the low. So we have a range. It can go from 15 kilograms per acre to 100 kilograms per acre, or whatever the numbers are. But it tells us how much of each chemical is used. So that's going to be perfect data to tie into those avian information, and we expect that it's going to be, we will be able to find statistically valid information. The next thing we're going to do is we're also going to look at the residue. How much pesticide made it through the food chain and was actually present on end food? The table that we have this comes from a thing called the Pesticide Data Program, and it provides us with a commodity, a pesticide code, the concentration found, and the state that it was found in. So there is one concern about this. A lot of these fields are sometimes null. Sometimes those field nulls have meaning. We have to deal with that. That's just something that we have to keep in track as we proceed. So our lessons learned to this point from that data is we've learned a lot about the process of gathering the data and how to assemble it together. And we've also learned that the residue data is not captured reliably locally. We have to deal with it on a state-by-state basis. We will. It's fine. But we also had a problem early. One of our initial data sets turned out to be not usable. We had to replace it, but we found a much better source anyhow. So the next steps are we're going to complete assembling all of that data into one cohesive data set, create the unified analysis sets to import into the visualization analysis tools, create our visualizations, and formalize our models with, of course, that target to have that paper done on the end of the last day of the class that we're all familiar with. So that basically wraps up everything that we have going on. We do have a lot of references, but feel free to review those. And if you have any questions, feel free to email questions or commentary to me. And other than that, I do want to point out that the presentation template was provided by Presentation Go, presentationgo.com, the birds template available on the internet. Thank you very much, and have a wonderful day.